In this video, we'll discuss sampling basics, so the ways that we select our samples to hopefully not get a biased sample. So there's two basic categories of sampling techniques. The first one is probability sampling. So in probability sampling, the odds of selecting an individual are known, or the probability of selecting an individual are known and can actually be calculated. The exact size of the population must be known, and it must be possible to list all of the individuals. So again, in order to do probability sampling, you need to know the size of your population, and you need to be able to list all of those in what's called a sampling frame. Each individual in the population must have a specified probability of selection. So if you know your sample size, you know your sample size is 100, you know that that individual has a 1 out of 100 chance of being selected. However, if you don't replace that individual, the next individual has probably a 1 out of 99 of being selected. The selection process must be unbiased and it must be random. So this is for probability sampling. We know the size of the population, we know the probability of selecting that individual, and it needs to be done in an unbiased or random process. And we'll talk about different ways this can be done. The second category is non-probability sampling, and this is where the odds of selecting a particular individual are not known. And while probability sampling is the kind of hallmark of sciences and psychology in general, as you go through and you read the articles that you're reading, you'll see that a lot of research is done with non-probability sampling, unfortunately. And that's the research that you'll do this semester will also have to use this non-probability sampling. So we're going to start off talking about probability sampling. So the first and probably the most common technique that students are already aware of perhaps is simple random sampling. Okay, so simple random sampling is when participants are selected from a list containing the total population, and there is equality to this. So equality means that basically each individual has an equal chance of being selected. And this is really important for random sampling or random selection. So each individual has an equal chance of selection. There's also this quality of independence. And so independence means that the choice of one individual does not influence or bias the probability of choosing another individual. So there are steps to this simple random sampling. First, we have to clearly define that population, and oftentimes it's listed in what's called a sampling frame. So we list all those members, we clearly define that population, then we list all those members of the population, and then we use some sort of random process to select those individuals. So some techniques, I mean, if your population isn't giant, you can put all those names into a hat and just select one out at a time, right? Until you get the number that you need. There's also computer programs out there. You can go to a computer program, put your list in, tell them how many individuals you want, and it'll spit out a random list for you. We used to use random number tables in the back of statistics books. My statistic book doesn't even have that anymore, probably because there's all these other techniques. Excel, if you could put your list into Excel, Excel has a random function, and so you could select your sample that way. So we're going to talk about the two principal methods of random sampling. And just keep in mind, the book uses random sampling. That may be a term that you've heard before. I also refer to it as random selection. So those terms, random selection, random sampling, really can be used interchangeably. So the first type of random sampling we're going to talk about is sampling with replacement. And so here the idea, this is really that it holds both the equality and the independence characters that we talked about in the last slide. So the idea is each individual has an equal chance of being selected, and the probability of selection stays constant. So imagine that I was interested in community college students, like we said before, and I decided I'm going to use Orange Coast College students as my accessible population. And I took all the names of those individuals and I threw them into a hat. And let's see, last year there was around, we'll say just 15,000 students. So I pull out one name. That's 1 in 15,000, you know, that picking that one person, there's a 1 out of 15,000 chance of that person being selected. Now, if I don't put that person back in, I don't replace that individual, the next individual has a 1 in 14,999 of being selected. So again, that's what that random sampling with replacement means, that I put those individuals back in, and that, to keep that probability of being selected equal at all times. So it's also known as independent random sampling because it has that quality of independence we talked about. Now, sampling without replacement is probably more common and probably more feasible, right? Because if I'm picking people to be in my sample and I pick one name out and I put it back in, I can't have that person be in my sample twice. So sampling without replacement is probably done more often, and it removes each selected individual from the population before the next selection is made. Now, while statistical procedures assume that you're doing random sampling with replacement, in reality, we said we don't really want the same individual in our sample more than once. And if you have a sufficiently large sample, like 15,000 students, is there a big difference between, and I'm going to pick 30. Is there a big difference between 1 out of 15,000 and 1 out of, if I can do the math, 14,970? Not a huge difference in that probability, right? So that's why we can still do sampling without replacement, and those statistical procedures are still pretty much okay. So some concerns and problems, of course. Chance determines the selection. It is possible, although unlikely because we're using random processes, to obtain a distorted type of sample. And there are other types of things you can do to try to avoid having a non-representative sample as well. So now, again, now that we talked about it, just which one of these do you think is more practical for research purposes? It would be the sampling without replacement, because again, we don't really want the same individual in our sample twice. So this is just a diagram kind of showing you, here we have our population and we want our population to be representative, so we use this simple random sampling technique. So now we move on to systematic sampling. And systematic sampling says that every nth participant is selected from a list containing the total population. So you choose a random starting position. And the positives is that it ensures a high degree of representativeness. And the bad is that it violates that principle of independence, because it doesn't ensure that one individual's choice doesn't bias the probability of choosing another one. Because if you start at one place, that spot, and then you go to the nth individual, that first starting place is going to influence the next individual chosen, and so on and so forth. So just for an example, here's my sampling frame listing the individuals in my population. I have 90 individuals just because that's all that would fit here. And then I use a random number generator to pick a random name to start with. So we've already gone online and you've used a random number generator when we did our experiment. And so you just put in, I need a number between 1 and 90. And that random number generator popped out 50. So I'm going to start here at this individual, number 50. Then I need to know how far I need to move down each time to select the next individual. So I take my population, which is 90, and my desired sample size. And my desired sample size is 15. So I divide the population size by my desired sample size, and I get 6. So that means I'm going to take every 6th individual. So I start at the 50th individual, and then I go down 1, 2, 3, 4, 5, 6. And I take this individual into my sample. Then I go down another 1, 2, 3, 4, 5, 6. I select that individual, and so on and so forth until I get 15 individuals. So there's also other types of sampling. So there's stratified random sampling. This is where your population is divided into subgroups or stratifications or strata. So that's where this idea of stratified comes from. So stratified random sampling, we divide into subgroups that are already pre-existing, and they probably are something that are relevant or may influence the outcome of your experiment. So subjects are randomly selected from each of these subgroups or strata. So let's say this is my population, and I just did stars for simplicity here, but and you can see the stars are different colors. We have gold, we have blue, we have purple, we have red. So that, and those different colors are meant to represent some sort of characteristic. Maybe it could be ethnicity or socioeconomic status or something like that. And I want to make sure that I have equal representation for each one of these strata. So I take them and I put them into these stratified populations. Okay, so I have a group of red stars, a group of gold stars, a group of blue stars, and a group of purple stars. And I then, if I want to have 10 individuals in my sample, I take 2 from each strata. So I make sure I have good representation of each one of these strata in my final population. So I randomly selected 2 red stars, I randomly selected 2 purple stars, I randomly selected 2 gold stars, and I randomly selected 2 blue stars. And again, you're randomly selecting those individuals in some sort of way using it could be using systematic sampling, it could be using random sampling without replacement, it could be, again, pulling names out of a hat, using a coin toss, using the random generators that are online. And then kind of taking it one step further. In some places it's not stratified and proportionate stratified random sampling are not differentiated. Here your text differentiates it, and I thought it was kind of a good way to see that, they really are different. And to keep in mind, I think a lot of places they don't, they just talk about proportionate stratified random sampling and not necessarily stratified random sampling, because proportionate is really probably what would be used most often. So here again, you're dividing your subgroups into stratifications, strata, whatever you want to call them. And then you determine the percentage of each strata in the total population. So this is where, if we're talking about stars or, ethnicity or what, you don't always have equal representation, right? Maybe it's 20% of this, 30% of that, 50% of this. And so really with this idea of proportionate stratified random sampling is you're random sampling from each of those strata, but keeping the proportion that's in the population the same in your sample. So subjects are randomly selected from each subgroup so that the sample has the same percentage. So again, let's say that my population, now we're just going to have red and gold stars, okay? And I have 40 red stars and I have 10 gold stars. So 80% of my population is red stars and 20% is gold stars. So I stratify my population. We can see how the red stars are much bigger. Now in my final sample, I want to make sure my sample has 80% red stars and 20% gold stars. So I randomly sample the number that I need to get that. And I'm doing a small sample again just for demonstration purposes, but I have a proportionate stratified sample. And so in order to get 20% with a sample of 10, I only needed 2 gold stars. So I randomly selected 2 gold stars. And then I randomly selected 8 red stars to be in my proportionate stratified sample. This is just another example with actual human faces. So here's my sample. I put them into different strata. Here looks like we have men, women, and children is how they've been stratified. And I want to make sure, so here they're all in equal proportions, so I don't need to worry about proportionate stratified sampling. But the idea is that then from each one of these strata, I would take a certain number of individuals. There's also something called cluster sampling. So here the population is divided into clusters, again, that are naturally occurring. This might be something like geography, classrooms in a high school, or elementary schools in a large city, something like that. And then the entire cluster is randomly selected. So with stratified sampling, we separated into strata and we sampled from each strata. Here we're taking pre-existing clusters that we assume that these clusters are going to be representative, or we hope they're going to be representative of the population, and we pick an entire cluster. So for example, let's say these were classrooms, there's 6 fifth grade classrooms at a given school. And we don't want to sample all of those classrooms because it's too much. So we just take 2 of those classes and Those two classes are our clusters, and that ends up being our sample. So it's an easy method for obtaining large, relatively random samples. Selections aren't really random or independent, but depending on what type of cluster you're selecting, you could get a good representation. So here's another example for cluster sampling that'll hopefully help. So let's say you wanted to your sample to consist of nurses from all of the United States. And yes, there's not enough hospitals represented here, but I didn't have enough space, right? So let's say maybe this is a specific type of hospital. And so you could obtain a list of all of the nurses in the United States, but that would be a quite large population, right? So you could obtain that list and you could do simple random sampling, systematic sampling, all of that. But that would be a lot of work because that's a large population. So instead, let's say we consider each one of these hospitals a cluster. So the nurses in these hospitals represent a cluster. And then we randomly select 10 of those clusters to be in our sample. So randomly sample all nurses in 10 hospitals across the country. So these circles are our clusters. Now I want to differentiate that from stratified sampling. So with stratified sampling, you have these pre-existing strata. And so rather than with cluster, you assume these to be a cluster. Here, we're going to say each one of these hospitals is a strata. And maybe they have different demographics for different reasons. So instead of taking 10 clusters for stratified sampling, we're going to randomly sample 10 nurses from all of these hospitals across the country. Cluster sampling, randomly sample all nurses in 10 hospitals across the country. We're taking those 10 hospitals as clusters. Stratified sampling, we randomly sample 10 nurses from all the hospitals. The hospitals are acting as our strata. Sometimes we use a combined strategy. So 2 or more strategies that are combined to select the participants. And this is going to optimize the chance that a sample is representative of a widely dispersed or broad-based population. So maybe when we're doing a survey or a political poll or something like that. So now we're going to touch on non-probability sampling. So non-probability sampling, one method is convenience sampling. And so here, the idea with convenience is here's our population, this is the researcher here in the little bullseye, and that experimenter or researcher is going to select participants that are convenient to them, the ones that are closest. So individual participants are obtained by selecting those who are available and willing. It can be a biased sampling method and so that makes it weak. But this is really what you'll be doing for the most part. When we get our volunteers for our experiment, it's out of convenience, and whoever is available and willing to come participate. So you will be doing convenience sampling. We won't have the ability to do any type of random sampling, but we will use random assignment, and hopefully that will help a little bit. There's also something called quota sampling. So this is when you're using a convenience sample, but you have subgroups that are identified to be included. So you establish you want a certain number of, if you want to keep maybe ethnicity balanced, the percentage, you only take a certain number. If you're going to have 30 in your sample, you only take a certain number of each ethnicity to make sure you have that balance. It allows the researcher for some control of the composition of the convenience sample, although the sample could still be biased in some way. And another way of thinking this is convenient stratified sampling. And I'll say that this is something to consider when you're doing your experiment. We can separate out and say we only want male subjects or female subjects. I know a lot of times people have said that they, had 2 males and 10 females in one of their groups. And so maybe there was bias there. It's something to consider, perhaps thinking about trying to control when we do our experiments, although the online nature might make that a little bit more difficult.